Okay. Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. I'm Jenny DiFigueretto, the community manager here for DVC. Today, we have a lot to cover to show you new ways to make the data wrangling of your computer vision projects much more organized and less costly. We have been working on DVCx for the past couple of years in response to the community's generative AI needs and are excited that it's almost ready. So let's jump in. Ryan Turner is one of our customer success engineers focusing on our new tool, DVCx. Ryan has worked as an ML engineer at companies like Uber and Twitter. He is now developing the platform at DVCai and has a great presentation and demo for you today. So the floor is yours, Ryan. Let's get started.
Yeah. Thanks for that, Jenny. So I'm Ryan. I'm gonna get started here with a new demo for some of our capabilities for handling computer vision data sets in DVCx. Some of you may have seen DVCx demos before. And if you have, we have some new stuff in this demo. And if you haven't seen any demos before, then it's even better because then it'll be all new, exciting stuff for you. So let's go right into it here. So about me. So I'm a customer solutions engineer here at Iterative, better known by DVC, because that's the flagship product is DVC. And today we're going to talk about the complementary product, DVCx. This brings us to our next slide. Just put these in here. So the origins of DVCx. So many people who've tuned in today are probably familiar with DVC. So that's been around for several years now, and it's a pretty popular product. It's been very successful. It's about version controlling data sets using sort of Git-like, foundations of Git, and it works really well. People have had a lot of success with it, but it's had certain limitations because it was designed in an earlier time when a lot of the sort of primary use case was for more tabular data and data that was still small enough that you could push it, pull it from a cloud source to your local machine and everything like that. And so the scale of the data wasn't too big. So DVCx is sort of the extra large or whatever you have form of this, where it's going to be a new complementary product where things have been designed a bit differently than DVC, that has been more specialized to the case of preparing and versioning your data and getting it ready to train these big models, these models of unstructured data, such as the generative AI models, where you really have very large data sets. And you don't need, any sort of, or you don't want at least any sort of copying off the cloud storage to your local machine. And the assumption at DVCx is that most of your data is going to be a huge collection of, say, images or videos or documents or whatever, and much less towards the already curated, tabular formats, right? It's a huge number of files, huge number of storage and everything. So things have been reworked from the ground up compared to regular DVC under this assumption of a lot of the sort of use cases that you're seeing now in the sort of generative AI space, for whether it be images or the NLP with, all the different open source variations of GPT kind of models. So this is the motivation for DVCx, right? And we're going to help people prepare their data sets to train these models, prepare them in a way that's very easy, and lets them focus on the part that I think people are more interested in, is spending time on the modeling part, not on the sort of data preparation, data cleaning part. And we try to make that as easy as possible, right? So to go into more details on that, I'm just going to go over three different slides here, some key principles or motivations in DVCx, and then go to the actual demo because I think that's what people want. That's what's more interesting, see the actual thing. But let's put a couple slides in here to set some context for what we're going to show in the demo. So the first thing is uniting unstructured data and metadata. So basically, we want people to have data frames that allow them to filter the data or clean missing data, impute some synthetic data in there. That's what we're going to do in the demo. But put things together and prepare your data in a way, aggregate it from different, maybe different sources or whatever, but do it in a way that filtering based on data and metadata is just as easy, right? So basically you put the unstructured data into the data frame, but do it without any copying. And this maybe is a little abstract, and it will become more concrete in the demo. There's a lot of the key principles that we can do this at very large scale. I mean, a lot of this stuff that we're doing here, if we're dealing with smaller scale data, things like, you could just probably figure out a way to do it with pandas. Not that hard. But pandas is, doesn't really scale to this big data sets. If there's something's a lot smaller and you can fit all these images or whatever into memory, then yeah, maybe just go use pandas, do a panda script, right? But a lot of data sets people are dealing with these days are not, they're not going to be something that you can fit in a memory like that. So also we don't copy data. Other tools might do that. So you might have a lot of copies floating around, which is something I'm going to get to here in the next slide. That one of our key principles from the ground up, from the very beginning, is that we don't make copies of your data from the original storages. And that's been a key design principle, which I think a lot of alternative sort of tools you might be able to use for this kind of data preparation don't follow. We just sort of virtually put data into the table using references and checksums and things like this, similar to what regular DVC does, really. Same sort of motivating principles, right? And so to elaborate that on a little bit more, because I think this is a key principle, this is a really key thing. There's a few different problems with making copies of the data, which I think a lot of other sort of tools might do under the hood. And the first thing is, and firstly, I'd say that these are sort of an escalating order of importance, in my opinion. So the first one is actually wasted storage, which costs money, for medium-sized data sets, because cost in cloud compute is relatively cheap. For me, you don't care about that for medium size, but for very massive data sets, there's a lot of stories of people realizing they've been wasting huge amounts of money on cloud compute by accidentally having a second copy of the data. But that's only for very massive. So other tools that make copies might actually move data out of the data center. This has been a complaint we've heard about other tools that people use. And that's problematic because, first of all, moving data out of the data center is slow, or even just, even within a data center, it can be slow. And then also it's expensive, because that's one of the things that data centers actually charge a lot for. Cloud compute charges a lot for moving a lot of data out of the data center. And then thirdly, I think this one actually might be the most important, if this is applicable to you, because if you handle a lot of confidential data, or if you're doing business, say in Europe, where you have GDPR concerns, the PII stuff is a really big deal. I remember this was actually a big headache, for instance, back when I was at Twitter, which is, how do you manage all the copies of the data sets you have floating around? Because say you have to actually delete a user's data, which you might have to if you're dealing with like GDPR kind of compliant countries, then you have to, you're going to have to keep all the bookkeeping of all the copies you've made, right? And then you're going to have to go and like delete it everywhere. And it's like, this is like a big headache, right? So only having one copy simplifies the PII issues if you have to actually clean up and delete stuff. So before we go into the demo, it's important also to go into this slide here, which shows sort of the big picture of what we're doing. So you have, any storage here on the left. We're seeing this area here. This could be any cloud provider, could be AWS, GCP, Azure, right? And then you're going to have, so we're cloud agnostic, right? So that's it. That's another important thing we do. But also, we're also format agnostic here, right? Because you've got, you can do images, audio, video, documents, whatever. It doesn't matter, right? That's the form of the data. We could also ingest all sorts of metadata. So you might have a storage bucket with tons of different like JSON files or CSV files or whatever scattered around with metadata, and a whole bunch of the actual media files scattered around in a bucket in any disorganized way. It doesn't matter because we can ingest it. Sometimes you get in situations where like a bucket was constructed by screen scraping, like from some sort of a crawler that went around the web, and then the directory structure is going to be totally crazy. Doesn't matter. So that's something that we can support. And so basically, we ingest it into a table. We don't make copies, as I was talking about. Instead, we just use references back to the storage bucket, but make it kind of look like there's a copy there, right? We kind of have a virtually stored in the table. And then we have tools to make it easier to filter, apply AI helper models, including on GPU, which is very important. Well, maybe not as important if it's something like OpenAI with an API call. You can do that, or you can do, these other tools that you run locally, like a Hugging Face model. This is what we're going to do in the demo, and then you just run it on GPU, and we'll also see how much of a difference that makes. That helps a lot that we support that so easily. And then then you export it to another data set, and then you can consume it, in your TensorFlow or PyTorch or whatever sort of data loader. And so this is basically where we want you to focus most of your time, over here in this terminal state of, in this chart. But of course, for you, this is really the beginning, right? Which is, where do I focus on the modeling, right? The modeling being what's really the interesting part for a lot of people doing sort of ML or data science type work. They want to focus here, right? All this stuff is this whole pipeline here. This is all this typical tedious stuff that's really boring and people don't want to spend a lot of time on. But in reality, in a lot of real projects, people spend most of their time on this kind of a pipeline. And we want to make that easier so you can focus on this part at the very end, right? And I think that, I think it's just a huge percentage of time in reality. That's been the way it's been in my experience. I think in a lot of other people's experience as well. If it's a lot different than, say, like, something like these Kaggle competitions where, it's all been prepared for you. People focus just on this, but on real problems, people spend most of their time on this whole pipeline. We want to make this a lot faster, right? So finally, one more slide before the actual demo. Is a key distinguishing factor is UDFs, or user-defined functions, with AI helper models. So in databases, you have this idea of a user-defined function, which is sort of a function you can execute on a row of data instead of like SQL commands or something like this. So if you're familiar with like BigQuery, for instance, they have user-defined functions, but and other databases do too, but very few of them have them in Python. And that's very important because you want to be able to access the ML ecosystem. And a lot of the stuff in the ML ecosystem is like Python libraries. So like BigQuery, for instance, which is, it supports UDFs, but it wants you to write them in JavaScript. That's just not very helpful for running AI helper models. So we support Python UDFs that we automatically send out to multiple workers with GPUs, and you can run AI helper models inside of these Python functions that you sort of run on rows of the tables. And we'll see concrete examples of this in a demo. Okay, so that's it for the slides. I said I'd keep the slides short. Well, I guess that was almost 15 minutes, but keep the slides short. And now I'll switch to the actual product here. I'll give you a quick overview. This year is this is DVC Studio. So this is our web GUI interface to DVCx. DVCx also has a command line interface as well, which is which might be preferable if you want to do sort of scriptable jobs. And a lot of the command line stuff is actually going to be available as open source too. So that people might get excited about that as well. So similar to DVC. And then here, this is our sort of commercial product, which is going to be the web interface to DVCx. So as a quick overview here, this is the storages. So basically, you just give it some credentials. So basically, you put credentials into which cloud storage buckets you want DVCx to have access to. And then you'll list them over here. So you have these here. So here we're going to do the DQ 50K Lion. So this is a small subset of the Lion data set. It's a huge computer vision data set that many people are probably familiar with. And so this lists all the different ones we have here. And then over here, this is where you can run your queries. And we have multiple different queries or scripts, basically. So in DVCx, the queries are just Python. So there's no weird, custom query language you have to learn. We do have an import. We have our own imports here from this DQL-lib, DQL query. So these are the DVCx sort of APIs that you call, but the actual syntax is just standard Python. So there's no weird language here. And then we run the query, the results show up down here in this bottom tab. And here's basically, it's just showing what's in a storage bucket. And once you have the results, you can register a query, save a data set, save the version, and so on. And then everything that's already been run shows up over here. So this is sort of the quick overview of the interface. This quick bucket here, this is basically just showing what's inside the storage bucket. Right, so the storage bucket can have any sort of arbitrary structure. So if you look at it here, this is a sort of an AWS console, right? So this is the sort of other ways you would look at what's in your storage bucket, right? You've got all these different metadata files and these, different directories and all these, images and metadata files and stuff like that, which it takes time to really go in and put those together in a more organized fashion. Here, you just create a data set from a bucket, and I'm going to look at all the different JPEGs. And then here's basically the JPEGs. We also have these system columns here, which can keep track of, E tags. And this is all the stuff for version controlling that is important. If you're familiar with how DVC works, it uses all sorts of checksums and everything under the hood. So we, of course, correspondingly keep track of everything very rigorously using these system columns, which you can also just enable or hide, whatever. So yeah, so then you have the data set here. You can also see which data set, which image, and download it, anything like that that's in your bucket. Very conveniently preview any sort of particular image in your bucket. So yeah, so basically this is a very basic command here that will just show you what's in your storage bucket. That's like the most basic thing you can do. So that's what I'm showing you right here just to get started. But now I'm going to deep dive into an actual sort of realistic example, right? So I'm going to look at the Lion data set, which is images and captions, right? If you're not familiar with it, right? The Lion data set has images and then associated captions coming from alt text. And basically the way it works is, you could do multiple things with this data set. One thing that people do is for these image description models. So you train a model to take the image and then predict the alt text to describe what's in the image. Right? And there's a variety of different models for this now. So what we're going to do here is we're going to prepare the data to be ingested by such a model. There's another, this is kind of similar to the data preparation task in this competition called Data Comp, if you're familiar with it. And I won't deep dive into the details on that, but that's sort of the similar task that this might help with. And basically what we're doing here is we're going to filter the data to remove, say, garbage images. And one of the results from Data Comp has been that removing a lot of garbage data actually helps a lot of downstream tasks. So it's actually really shrinking the data set actually increases performance, somewhat counterintuitively, you might say. But so So yeah, so that's what's going on here. And yeah, so what we have is we're going to prepare the data for this type of a task. And we're going to remove a lot of the garbage images. We're going to remove some of the garbage captions, and then we're going to fill in some synthetic captions. That's the task, right? So basically, I'm going to show how you can ingest metadata using DVCx. So basically, you can so what we can do here is we can just go into the bucket, retrieve all the JSON files, which are scattered throughout the whole bucket. So there's all sorts of disorganized JSON files. And basically, we can just use our JSON extractor, the library we have here, to construct a structured data set from all the JSONs that are scattered throughout the storage bucket. So then you can preview in the tool here. See, this is all the, these are the JSON previews. This is basically all the information, all the metadata, and then here we have it in a more structured form, which is you might find very, very useful for the next task, right? So then we can also take the metadata and then also ingest the data, right? Go find all the JPEGs files and merge it together with the metadata, and then do a filter. This is just filtering out any things that would be inappropriate for demo. And basically here, this is our entire data set. So we have all the different images in our line data set and all the associated metadata. Only a few lines of code necessary to get here. Pretty easy to all ingest it. This would be kind of tedious otherwise. So basically, yes, you can just click on an arbitrary image and see it in the preview. You can see all the metadata right here. I see the caption, which is the most important part, because the caption learning is what we're going to do in this demo. So basically, we see the data, and then we can also do a basic filter on the data right here. So basically, what we have is I'm going to show some. Basically, we have this filter command, which you can use to filter out the data. Basically, you can use look at, say, the width and height of the data of the image, right? So basically, one of the main things you want to do is filter out garbage images. So remember, this data set was constructed by screen scraping. So you might have all sorts of weird little border icons and tiles and things like this, 1 by 1 pixel images. So you want to filter all that out. So basically, you can filter it out, and then we can also mark a caption as a bad caption. So here's demonstrating how we can use a Python UDF, a Python function, to mark a column as good or bad. So this is an example of how to use a Python UDF, which is something that, as I mentioned before, is something that if you were to use other tools, if you were to somehow ingest this all like into BigQuery, it's just writing a simple Python function like this is not really possible. So this is something we support. It's very easy to do. Just write a simple Python function to add another column to the data here. So it's like, okay, most of these captions are good, but there's one bad caption right here. So this was very easy to do, right? And then finally, the final thing I'll show here is what I'm going to do is impute the caption. Take those bad captions, remove those captions, and fill them in with the BLIP model. So we have all sorts of little connectors to very seamlessly run models that are hosted on Hugging Face very easily. Just a few lines of code, import, boom, and it runs. So just import BLIP2 describe. So what we're going to do in this demo is just take those bad captions effectively, right? We're going to delete the bad captions and then synthetically fill them back in with BLIP, right? And we can do that very easily here. We can take the original data. We can basically what we do here is the way we do it is you're going to split the data in two. You have the the data with the good caption, the data with the bad caption, and we're going to take the bad caption data and fill in the BLIP model, use BLIP to fill in synthetic captions and join it back together, right? And then that's what we have here in the preview. This is the entire data set again, but now that the bad captions have been filled back in using the BLIP model instead of the original caption. So the first row of data, this was a bad caption. The second row was a good caption. So you can see here, yes, what this data had a bad caption, and this one was a good caption. I don't know what that is. And basically, if you go look at the caption, this is, was a synthetically imputed caption, basically. Some Essence gel nail polish on it. Looks about right for the image. And this is one where the original caption was something that was, say, like, just untitled or something like that. And you want to then replace it with a synthetically generated caption. Because sort of a data imputation task. And basically, so one last thing I'm going to show on this demo here is, you can see here, this is the execution time. This took 3 minutes and 30 seconds because we support GPU on Studio, on DVC Studio. We now support GPU. So this can run very easily. This is through whatever the however many thousands of rows this was. And I'm going to show the exact same. You can also see over here, we have the exact same query, but you can hard code device equals CPU. And it was 45 minutes. So that was definitely something to, I'm sure many people are familiar at this point with all the advantages of running stuff on GPU, but it's just good to see a side-by-side in Studio, that advantage that we just automatically support this. If you are going to use DVCx Studio for your project, then there's no extra setup. There's no setup or configuration involved to get hooked up to some sort of a GPU machine, as it might be with some other products where you gotta jump through some extra hoops to get running on GPU and get these huge, more than 10-to-1 speed increases. It's just there for you automatically. Not trying to say we're the only people that do GPU, of course not, but we just make it easy without any extra hoops to jump through. So I think that is about it for the actual demo. So now I'm going to take any questions, and I'll leave it at this slide as well while I'm taking questions, because if anyone is interested in trying this out, getting some sort of a trialed, more demos, more information, they want to use it for their actual project, then go to dvc.ai and hit that contact us button right here. Here's our homepage. You just got to hit the purple button, and we'll get in touch with you very, very quickly. So just leave this up here, and if anyone has any questions, I am ready to take those. We have plenty of time, so we schedule it. I have a whole hour scheduled here, and the actual demo here is just half an hour. So if anyone has any questions, plenty of time to answer them.
So yeah, we do have a few questions. First question is, can I use Pandas functionalities inside the UDF?
Yeah, of course. That's definitely possible. Anything that you can do in a standard Python script, you can put inside a UDF. There's no, it's just Python code, basically, right? It's arbitrary. A UDF can be arbitrary Python code. So if you want to use pandas inside of there, that's fine. Some Python code is going to run faster than other Python code, of course, but you can do it, of course.
Cool. So this came up too. How is DVC related to DVCx? How do they?
Yeah. So that's a good thing for me to elaborate on more, because that's something that I sort of alluded to at the very beginning on the first slide, but it's something that comes up a lot when I talk to people about DVCx. So as I mentioned before, DVC was sort of oriented towards these smaller data sets that doesn't have certain constraints that DVCx has. This sort of idea that you never actually want to be copying the data set, especially or especially moving the data set in its entirety to your local disk, right? That was something that was not really a design concern in DVC, but it is in DVCx. And they can also be used as complementary products. So DVC has a lot of capabilities like which don't exist in DVCx at the moment, and like things like managing pipelines, right? You can organize all sorts of pipelines of multiple steps of training, and for like the DVC repro command, for instance. We're also working on sort of ways you can sort of use the tools together. So like use DVCx as a stage in DVC. So you can say, if you're working with a massive data set, you may run some DVCx commands and then generate something that you could actually store in DVC. If say the final data set that is generated is smaller, say you're working on an example where you're using a whole bunch of images and all sorts of unstructured data, but say the final resulting data set from DVCx is something with like a bunch of embeddings, right? A subset of the data, and it has a bunch of embeddings. You're not actually working with the original data. Then the data set's a lot smaller. So then maybe from that point onward, you want to just check it into DVC and just use regular DVC. That's a pipeline that we envision, which might be a very common use case, right? Where you start with some just totally massive petabyte size data with millions of images, and then you just you filter it, and then it gets smaller by working with only embeddings, and then at that point regular DVC is appropriate, right? That could be a very common situation.
That was part of the next question that came up, was, are Python queries backed by Git in any way? So like this is a workflow that would work that way, right?
Yeah. So yeah, that's one feature of DVC that I think is something that regular DVC, that is something that it is really a distinguishing factor between it and say anything else for managing data sets, is the fact that it builds on top of Git, right? So we don't use Git for built in Studio for managing the queries. If just the sort of what I showed in the demo, it's not using Git in any way under the hood. That said, you can put your DVCx queries into a DVC pipeline, which is then get managed by Git, right? But if you're just doing what I did in the demo, just use the web UI, then that's not using Git under the hood. But you can use it that way with DVC to use, okay, we're going to version control all these different queries into a DVC pipeline. And then if it's in a DVC pipeline, it's all built on top of Git. And, so the answer is yes, but not if you're doing it the way I did it in the demo. That doesn't need Git for what I did. So.
Okay, cool. There's a new one that came up. Hello, thank you for your demo. Does it work with multispectral images, satellite images?
Well, I guess maybe I need more details to know exactly what that's what they're asking about. But I think there's a couple points that I'd like to make on that. So first of all, DVC just works, or DVCx basically works with any large binaries, or small binaries, but like any just binary files in your cloud storage bucket, right? So it doesn't matter if it's what modality it is. So that's fine. It doesn't, it could be image, it could be video, it could be whatever. So if you have if you're dealing with satellite imagery and those come in some sort of special format, then that's fine. It doesn't matter, because the core functionality of DVCx is based on just arbitrary binaries. And with regards to the satellite imagery, though, that is something actually we've talked about a lot with other sort of potential customers we've talked to. It's a lot of we get a lot of questions about that, and sort of putting in some features that would be useful for satellite, for that kind of imagery where we have like big satellite imagery. That's something we talk about a lot. We don't have any existing customers doing it, at least that I'm aware of. But we would like to learn more about that particular application, because it's something that we are always talking about. Certain potential customers talking about some of there's certain idiosyncrasies of satellite imagery that maybe they might want a certain feature for us to implement for that. So we would be curious to learn more about it.
Yeah, but reach out, use that link or that we put in the chat and the thing, and we would love to explore that with you.
Yeah, something we definitely have in mind throughout the process of building this. Like we don't currently have a customer doing satellite imagery, but it's something we know we might in the sort of not too distant future.
So another question: who pays for the cloud resources and how? How does that work with DVCx?
Yeah. I mean, so we're still in a sort of pilot stage of, it's in early stages. So that, might be worked out on a case by case basis. I mean, I think eventually the sort of images, the idea is that, the customer is paying for the compute resources because, it's, GPUs, can't just give away GPUs for free these days. The way the kind of at least not in an unlimited basis. Maybe we can give away GPUs for free instead of in a limited sense, but not in an unlimited sense. So yeah, that's something that we'd have to talk about if we have potential as a potential customer. We can talk about how to deal with that. But it's sort of the big picture is ultimately that customers gonna have to pay for some of these resources. It's not like we're unlimited. It's just these GPUs, unlimited GPUs for free here.
Right. Yeah. Next question is, how is that different from other products like Snowflake?
So we've been actually, we have been looking at a lot of stuff lately about, it's very important about, there's a lot of people doing these sort of tools for, deep learning and these big data sets that might be in the sort of Gen AI space, for instance, right? So we have been looking a lot at, well, what else is out there, because things are evolving so quickly. Let's see, I had a slide here. If you go back to the first slide, here, the uniting data and metadata, we do talk about some of the other tools. Snowflake, in terms of the differences with Snowflake, I'm not sure exactly which capabilities. I know that their capabilities are going to be similar to what Databricks offers. And I think we have been looking a lot more at that, which would be in terms of what Databricks offers, it's there's a lot more copying under the hood, for instance, which is, as I mentioned, could be problematic in certain situations, or a lot of situations. That's one of our key differences, and also there's more glue code for some of the solutions that they offer, because it wasn't designed. I think a lot of their tools weren't designed for necessarily this use case, from the ground up. It's something they're trying to support stuff like this kind of after the fact, after designing their core tools for something else, sort of just like what we did here, right? We had core tools for DVC, right? But instead of trying to band-aid DVC to do this kind of stuff, we're gonna build a brand new complementary tool. So that's sort of one of the key differences as well. I mean, at a high level. But I'd like to answer more on this. I should look more at the Snowflake, but anyway.
Okay. Next meetup.
Yeah, exactly.
So, do I need to be a studio user to use DVCx?
No. As I mentioned at the beginning, we do have a command line as well, which I guess maybe in the next meetup we can demo the command line, because that's if you're going to integrate it with DVC, that's probably what you would use, is the command line interface. So everything that I did in Studio, you can do also on the command line. There's an equivalent command for it. So that's the important part. And also, a lot of the command line stuff is going to be open source too. So you won't even have to be a paying user. So a lot of functionality you'll be able to get even in an open source version if you're happy with the command line. So so you don't need to use Studio for that. You can just use the command line version
library. Yeah. Okay.
Similar to DVC. Right?
Mm-hmm.
Similar story. Regular DVC.
And then the last question we have right now is the product available now?
So the DVC, we're going to do the open source for DVCx is very eminently going to come out. So that's like the command line version is eminently coming out. And the Studio, which I showed in the demo, it is available now because we do have a couple early customers, and they're even on like pilot customer kind of deals. So it is available. The sort of general release of sort of the open source is going to come out very soon. But and then in Studio, the sort of the paid version, that is available as like a pilot customer basis right now. But you do need to hit the contact us button. So I guess it's not available without hitting the contact us button. You have to hit the contact us button at this point still.
Cool.
Mm-hmm.
All right. Well, that's all the questions that we have. I want to thank everyone that showed up today and attended, and this will be online in the live videos on our YouTube. We have all the links to things in the comments here today, but also will be in the description of that. And so we plan to do these use case videos like once a month so that you can see all the new use cases that we're adding. And by all means, reach out to us. We would love to talk to you about your use case and how DVCx can help you in your workflows. So with that, have a great day, everybody.